We used to think oceans required sunlight, but 628 million kilometers from Earth, a frozen moon challenges everything we thought we knew about life. Europa, Jupiter's moon. A smooth, cracked sphere of ice, smaller than our own moon. It looks silent, lifeless, forgotten. But beneath its frozen crust lies something extraordinary, a vast planet-wide ocean, buried under up to 25 kilometers of ice, permanently dark, crushed by intense gravity, heated by tides instead of sunlight. And this ocean may hold more water than all of Earth's oceans combined. A world we cannot see, a world that may already harbor life. If we ever find it out there, Europa might be where it begins. Europa's surface tells a story. It's one of the smoothest in the solar system, but not because nothing happens. In fact, it's the opposite. Crisscrossed with thousands of kilometers of ridges and fractures, as if the entire surface has been shattered and refrozen. Giant blocks of ice have drifted apart and rotated, like shattered sea ice on Earth. Some regions look like they've been melted from below, then quickly frozen again. There are rust-colored streaks across the ice, possibly salts or sulfur compounds. This is not a dead moon, it is a restless one, and the patterns on its surface suggest something moving beneath, a dynamic ocean. In the 1990s, NASA's Galileo spacecraft began orbiting Jupiter. It flew by Europa repeatedly, measuring magnetic fields, gravity, and surface composition. The data revealed something unexpected. Europa had a magnetic field, but it wasn't coming from Europa itself. It was being induced, like a wire moving through a magnet. That meant one thing: a global layer of conductive fluid beneath the surface. Not lava, not iron, water. A global ocean of salty liquid water hidden beneath the ice. Later studies suggested this ocean could be over 100 kilometers deep, far deeper than Earth's oceans, and with a thinner crust than previously believed, maybe as little as 15 kilometers. This changed everything. Europa wasn't just interesting, it became one of the most promising places in the solar system to search for life. But how can liquid water exist so far from the sun? The answer: tidal heating. Europa is caught in a gravitational tug-of-war between Jupiter and its neighboring moons. This constant squeezing creates friction, and friction creates heat. The same process fuels volcanoes on Jupiter's other moon, Io. But on Europa, that energy keeps the ocean beneath the ice from freezing solid. This tidal force may even power underwater currents, melting parts of the ice from below and pushing warmer water upward to the surface. Beneath the ocean floor, contact with Europa's rocky mantle may allow hydrothermal vents to form, just like the ones on Earth's seafloor, where life thrives without any sunlight at all. No one has seen Europa's ocean, but science can model it. Imagine a layer of solid ice, smooth, bright, frozen. Now imagine that shell floating on top of a vast abyss, an ocean over 100 kilometers deep. No light, no air, only pressure and motion. Water circulates through convection. The base of the ice melts and refreezes, carrying heat and minerals upward. Sometimes cracks form, and in those moments, the ocean may breach the surface. In 2013, the Hubble Space Telescope spotted what looked like plumes of water erupting from Europa's surface, shooting over 100 kilometers into space. If confirmed, those plumes mean we wouldn't need to drill to reach the ocean. We could sample it from orbit. This is where the story shifts from planetary science to astrobiology. Earth's deep oceans host entire ecosystems that live in total darkness, thriving around hydrothermal vents. Instead of photosynthesis, they use chemosynthesis, drawing energy from chemical reactions. If Europa has similar vents, could life emerge the same way? Scientists believe so. Europa's ocean has everything life needs: water, heat, time, energy sources, and possibly the right chemistry. Even if only microbes exist, it would be the most important discovery in human history. But some scientists go further. They imagine entire ecosystems, floating bacteria, filter-feeding colonies, pressure-adapted organisms that never knew sunlight. If life evolved independently on Europa, it proves we are not alone. NASA is preparing to go. The Europa Clipper mission will launch soon, armed with radar, magnetometers, cameras, and spectrometers. It will orbit Jupiter, flying past Europa dozens of times, mapping its surface, scanning the ice, and searching for plumes. Its goal: to understand the ice shell, the depth of the ocean, and whether the conditions for life truly exist. Later missions from NASA or ESA may attempt to land, maybe even drill or melt through the ice. The hope? To one day reach that alien sea and listen for the faint chemical signs of life. Europa doesn't glow. It doesn't roar. It doesn't call attention to itself. But it may be the best place in the solar system to find alien life. A world with more water than Earth. A world shaped by tides, not sunlight. A world with an ocean that has never seen the sky. The answers we seek about life beyond Earth might be waiting there, silently swimming beneath the ice. And when we finally arrive, we may not be the first to call it home.